Welcome to part 2 of trigonometry. In this part, we will study some definitions and the values of some trigonometric ratios based on all the derivatives that we have done in the previous part. So in this part, we will take up sine, cos and tan and figure out its values for certain angles such as 30 degrees, 60 degrees, 45 degrees, and at different angles what would be the trigonometric values. Also in this part, we will know why these angles and these particular angle values are important to us. Based on that, we will look into all the trigonometric values and try to figure out the whole table of the trigonometric ratios. Hi, in this part we'll look at some specific angles. Like we have already defined that for a particular angle, what would be their corresponding values in terms of the ratios. So in this part, we'll take those values as different angles and try to take out the values of the simultaneous ratios. So let's say I start off with the trigonometric ratio of 45 degree. So in this 45 degree I have, let's say I have a triangle of right angle triangle like this. So in this, I can have this as my side A, B and C. Remember, whenever we are dealing with trigonometry, one should always try to draw the right angle triangle so that we know which value stands for which. So let's say over here, this becomes my 45 degree. Okay, so simultaneously this will also become my 45 degree, right? The sum of angles of the triangle has to be 180 degree. So by that, if this angle is 45, this will also be 45. So if that is true, then my BC and AB will be equal. Why? The base angles are, when the base angles are equal, the adjacent sides are always equal, right? So from that, I get my BC is equal to AB. So let us suppose that my BC is equal to AB is equal to some value of A. So if that is true, then by applying Pythagoras theorem, I can take out a value, right, for AC. So my AC becomes root 2A. So if I put it in definition of sine 45 degree, I get as 1 by root 2 and my cos 45 will also be 1 by root 2. Now this is the easiest one of all. Okay, so if this is right, then I'll have my tan 45 will also be equal to 1. So in this case, let's say I have defined all my angles. Alright, so simultaneously I can get all these angles as like this. Now let's look at this triangle. Okay, just remember this triangle over here, and this is actually an equilateral triangle. Okay, why do we need it? We need it to define over here. So for finding out trigonometric ratios of 30 degree and 60 degree, we basically need an equilateral triangle A, B and C, and we draw a median right over here. This is my T. So this will be 90 degree, right? For a median in a equilateral triangle, this becomes a perpendicular. So I have my two triangles ABD and ACD. So these two triangles are congruent to each other, right? So if these are true, then BD will be equal to DC, right? So from all of this, I can get, also I can define that my angle BAD will be 60 degree and the other will be 30 degree and this will be 60 degree. So how we define this? So let's say I had my AB as 2A. So therefore my BD will be equal to A by 2, right? That is half of AB. Therefore, if my BC were 2A, then my BD will be equal to A, right? So I can have, using Pythagoras theorem, some value like this. This will be root under 3a. right? So I have my AD is equal to root under 3 of A, right? So if I put all the simultaneous values in place, I can get values for sin theta, I'll get 1 by 2, for cos 30 degree I'll get root 3 by 2, for tan 30 degree I'll get 1 by root 3, for cosec 30 degree I will get 2, sec I'll get 2 by root 3. Simultaneously I'll get all these 6 values right over here. Okay. Now similarly, if I had for sine 60 degree, the angles ratio would be opposite. So I can get as root 3 by 2 is my 60 degree, and for cos I'll get 1 by 2. Let's move on. So the other values will simultaneously be 2 by root 3 and sec would be 2, cot 60 would be 1 by root 3. So the trigonometric ratios for all these would be has been defined like this. Now for trigonometric ratios of 0 and 90 degree, how do we do it? Let's see, if I have the trigonometric ratios of angle, if it is made smaller and smaller in the right angle triangle of ABC till it becomes 0, angle A gets this smaller and smaller, right, and the length of the side BC decreases. So the point C gets closer to the point B, and what it leads me to is it finally, when angle A becomes very close to 0, AC becomes almost same as AB. So when I continue with trigonometric ratio of 0 to 90 degree, I have angle A very close to 0, BC very close to 0, right? So the value of sine A will be also close to 0. Why? Because BC is getting close to 0, so 0 by anything will be 0, right? So when angle A is very close to 0, AC is nearly the same as AB, and the value of the cos is close to 1, right? Why? Because value of AB is close to AC, right? So I will get my cos of that value as 1. And this helps us to see how we define the other values. So sine A and cos A, when A is equal to 0, my sine 0 degree is equal to 0 and my cos 0 is 1. So if I remember this, I can define the rest, right? So that leads me to tan becoming 0. Why? 0 by 1, it is 0. Cot 1 by tan, which till date has not been defined. 1 by 0 is not defined, so we always write it like this. Okay, continuing, for 0 to 90 degree I'll get all these values also, right? So in all the cases we see, for all the 6 trigonometric ratios and for all the 5 values, we have defined everything, right? So we all know all the values for all the trigonometric ratios for 0, 30 degree, 45 degree, 60 degree and 90 degree, right? So if I take all the trigonometric values, if you do it into them, I can always have for trigonometric ratios these important points. So whenever the angle is getting to 0, one angle, the other angle will always be close to 90 degree, right? So the sides will also merge simultaneously like that. So what that gives me is, basically when I define them, I have my sine 90 degree, for 0 it will be 1 and for cos it will be just opposite, right? So basically if you swap the cases of 0 to 90 degree, I can get all the values of sine and cos. So ultimately I have a trigonometric ratio table of all the values. You see, we have defined the sine for 0 degree, sine for 60 degree, 30 degree and 90 degree, right? So I need to just, if I know for sine and cos, I can basically define everything. But if there is an interesting part over here. if you look at the sine and cos, you see the value of sine 0 is equal to value of cos 90, the value of sine 30 is equal to cos 60. These two are also equal, these two are also equal, and these two are also equal. So basically what I can do is, if I know all the values of sine theta, I can get all the values of cos theta also, right? We just need to swap it in a zigzag form, right? And obviously I can calculate tan based on that. Tan theta is my cos theta, sin theta by cos theta. So I can define them like that. And cosec, sec and cot we know how to define. So the ultimate point is, if you know the value of sin theta, you can calculate the value of any other trigonometric ratio. Okay. So with this part, we come to the end of part 2. Hi. Well guys, that was all about part 2. So what did we learn? We learned the angle values of certain trigonometric ratios, and based on all of these, okay, based on all the derivation, now in our next part we will look into the whole trigonometric table. We have sine, cos, tan, cot, cosec and sec. So all these trigonometric ratio, all 6 of them, and their corresponding values of 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. So from all of this, we have tried to figure out this part. So in the next part, we will come into the other set of values, for which based on that, we will define some of our trigonometric identities and the basic trigonometric formulations that we have.